G'day. Starting work on a new standalone netProbe project that will run on an Esp32. I made something similar in the past and I called it OurProbes project. That allowed me to monitor network latency, bandwidth, and HTTP website availability and responsiveness. However, I was needing to rewrite the OurProbes project. I was using Google Cloud service called IOT Core that Google has stopped supporting. Also, something I wanted to improve on in the rewrite was to simplify the functionality. The original OurProbes supported having multiple distributed probes running at the same time and being coordinated from a central management application. That was overkill for what I needed. I only need to monitor some devices on my home network and one or two websites on the internet. With netProbe, I want to focus on functionality running on a single microcontroller with an Angular UI to manage the device. This is similar to what I just did on the SolarGarden project, so it should be pretty easy to take code from that project and code from the original OurProbes project, blend them together to make netProbe. For this project, I'm going to use an Olimex device. I've used this before. It's good because it's got a Ethernet connection on it, as well as wireless Ethernet. It has a Esp32 in it, and also supports an SD card if I need that for holding the log files. Here's a look at it. So I used this before for the OurProbes project. So I put a link down below where you can get the Olimex board. You used to be able to get it on Amazon. They don't seem to have it anymore. Next, I wanted to download the latest version of micropython. So there's a version out there for the Esp32 Gateway from Olimex. One problem I had with my main PC, I wasn't having any luck using the ESP tool. Didn't seem to be able to write, and I saw on the web that there were some timing problems with the driver for the Olimex board for some computers. So I actually used an old Surface Go, which was a lot slower, but seemed to write out, erase the board and write out the newest micropython firmware to the board. Okay, so it's architecture and design time. That's about all I'm going to do. So to make the netProbe application, like I said, I'm going to merge together the SolarGarden functionality with OurProbes functionality. So the OurProbes bit is really this part on the right hand side. So I had routines in there for doing pings or network pings, network bings, which is a way of finding bandwidth using icmp packets, and being able to do HTTP tests where I test a certain website, check that it comes back with a string in the response, and all that goes through an internet connection. And since I'm using Olimex, that can either be wireless or Ethernet. And I'm going to have a configure file out there, just be a config.json type file, which will have details about what the IP address of the device should be and which interface it should use. So a lot of that is already in OurProbes. I just need to pull the routines and the libraries over. The other half of this is really coming out of what I just did for the automated garden project. So in that I had to set up a little website to be able to provide web services, as well as have a scheduler where it could run timed things at certain times. And so for that, it's all in MicroPython. I used the microdot library for providing the web services, and I used a little async.io routine that woke up and ran in the background to fire things off at certain times. So I'm going to do the same thing. So my scheduler is going to wake up every so often, check a file that I'm calling hosts, which has the list of hosts and the tests that I should run on each of those hosts. So again, it can be only one test, one of each of these sort of tests per host. So either a ping, a bing, or an HTTP request. It can do any or all of those three things on a particular host, and it'll be scheduled to run, say, every 5 minutes, every 20 minutes, whatever I set it up for. So the test scheduler will be doing that, reading hosts, running these routines, and putting the results into a results file. And then the microdot web service will have web services that do things like get the list of hosts, get the hosts and the latest results, allow you to update host details, so update the tests and what hosts are being tested, and also do things like delete hosts. It'll also allow you to get results so that we can see what the latest results were, as well as being able to get results for doing charts of particular results. And like I said, a lot of this I've already done in the SolarGarden project, so it shouldn't be hard to transfer it over here. And I know it runs on a micropython. Then for the interface, like I said, I want to simplify it over what I had in OurProbes. So because it's all just running on one device and only ever is running on one device, I don't sort of need the distributed device management that I had in OurProbes. So I think the interface is going to look something like this. I'll have a mains web page, again, provided by the microdot web service. And I'm going to have an Angular application in front of that, just like I did in the SolarGarden project. So the Angular application will show basically a list of hosts and the tests that they support and the latest results for those tests. And then from there, for each host, you can also press the edit button and get into a page that would probably look something like this, where you can set up each or all the 3 tests that can be applied to a particular host. Click another button to take you to the charting function, where you can chart any of this data. And then also have a delete button there, where if you want to delete a host, you can just click on that, go into the host page and do a delete. So that's kind of what I'm thinking the interface is going to look like. It's probably going to look a little more complicated than that, but should be a lot simpler than OurProbes anyway. And finally, I'm thinking I'm going to end up with a bunch of different files needed to support this. So I'll have probably one hosts file, which will just have JSON data with a JSON object for each host, which has the information about the host name, how to get to it on the internet, and the tests that host supports. Like I said, I think also have a config.json file. They'll have information about whether I'm using the WAN or the Wi-Fi interface for network connectivity, passwords for the Wi-Fi if we're using that, and the IP that I want the device to start with. So I'll just give it a static IP on the address, but I can specify in the configure file. And finally, for the test results, I'm thinking again it's going to be kind of what I did with the SolarShed and SolarGarden, is have a separate results file for each day, and then also a separate one for each host. So on a particular day, you could have multiple files with a host identifier as a 2-digit number at the end of the actual day information. So something like TR for test results, year, month, day, and the host number .json, and they'll have all the results for that particular host in it. I got a feeling that at least the test results, there could be a lot of files and it could get pretty big over time. So the other good thing about the Olimex device is it supports an SD card. So if I find I'm getting it tight on space on the built-in file system on the Olimex device, then I'll swap over to having this, or maybe all of these out on the SD card. It may be useful for having something like the configure file on the SD card as well, and then it's easy to update it. Just pull the card out and use a text editor to update any information I want there as well. So I'm ready to start coding. I'm going to start, you see here I've created a netProbe project inside Visual Studio Code. I've already used pyMakr to connect it up to the Olimex device, and that's showing there okay. And it's already synced up to a GitHub repository, and I've got the link down in the description there for people who want to follow along. So first thing I need to do is I'm going to bring over the OurProbes functionality that I'm going to use first. So like I showed in the diagram, probably the first thing I'll bring over will be the connection to the internet, and on the Olimex device that can either be through the Ethernet connection or through wireless. So I think I'll code that up first. So I'll get the connection type from the config.json file, get the details about the connection, things like whether it's using a static IP address and stuff, and check that I can get the code going for connecting, and I can make use of some of the code that's already in OurProbes. So I've got an example of all these things starting up by going under source, micropython device, and down here is my OurProbes micropython code, and in main that's where I was connecting up, doing the connection to the device, whether it was Ethernet or Wi-Fi. So example of it's there. So I just need to add some code in to get the details out of the config file and do the connection, and then I'll test that just to make sure we're connected to the network. After that, the pieces I'll need things like the microping.py, microbing.py for doing bings, and the microwebpage.py. I know microwebpage.py is also making use of the microweb CLI py library. There's probably some other dependent libraries maybe for ping as well, I'm not sure, but I think there may be some dependent libraries for doing the pinging as well. I also had a look through here, and it looks like I've got like some testing functions out here, so for testing out like connecting to the network, they'll be useful. I'm testing things out, so I'll probably pinch some of that code as well for doing some tests. So first thing I wanted to do is get the network connection going on the Olimex. So I created this netconfig.json. I actually changed the name from, I just called it config, but netconfig makes more sense for this file name. And it's a JSON file, has information like whether to use Wi-Fi or not. Otherwise it'll use the Ethernet connection on the Olimex board. Whether to use dhcp to get the IP address and gateway and things, or else if that's false, it'll use the values in here for connecting to the network. Whether to use, if I'm using Wi-Fi, what the Wi-Fi SSID and the password are. So again, these things are option. If these are both true, then you wouldn't need any of these bits. And also what NTP server I want. I can leave this out and I'll just use the default for MicroPython, but I put it in to use my my home NTP server. So what I'm doing is I put together this netconfig library. So it's really a netconfig class. Has the name of the netconfig JSON file declared in here. And then what happens is when this class gets initialized or gets when I make an instance of this class, it's going to call getConfig, which is this code down here. So first it's going to check whether the netconfig JSON file exists. If it doesn't, it'll raise an exception. And you'll see down here I'm raising exceptions if some obvious things are missing from the JSON file as well. So otherwise it opens up the netconfig file. It reads the whole netconfig file into a MicroPython object called network. Then it goes through the network and checks whether items are present that should be there. So first does things like this, goes and looks for Wi-Fi SSID and network. If it does, then it assigns it to self Wi-Fi SSID, which is one of the class properties up here. And so it's on through here. For more critical variables in the netconfig.json file, like use Wi-Fi where it has to exist. Then it's going to transfer it. It's going to check whether it's the right type, and if it does exist, then it's going to also check that we actually have the Wi-Fi password and SSID defined, and so on through all the variables. So this is the way I set up a class representing the netconfig file. And then if we go to main, we see in here, so when it fires up, the main activity it's going to do is just call the connect subroutine down here. And in this connect subroutine, I'm setting up a LED just so I can see how the network connection's going if I'm not actually signed into the device. And then first, like we saw, it'll make an instance of netconfig, and then it'll check whether we're using Wi-Fi or Ethernet. If it's Wi-Fi, it sets up the appropriate interface. Otherwise, if it's not Wi-Fi, it means it's using Olimex's Ethernet, then it sets up the interface for using that. One change from my earlier version is before I had to set this clock mode. That no longer is in the LAN definition in micropython, and I think what's happening is because I'm installing the Olimex specific version of micropython, that's already been set up in the background, so I could just omit it from the list of things I need, parameters needed for setting up the LAN. After that, it makes the net interface active. If it's not dhcp, which means I need to pass the IP, the net mask, the gateway, and DNS to the configuration for the net interface. So that's what I do here. If it's using Wi-Fi, then this is where we need to connect to the Wi-Fi using the SSID and the password. Then it's going to sit in this loop until it's actually connected. I found it doesn't really tell me whether it's connected until the interface's IF configuration has a IP address other than the default in it. So even though I used to use these, for some reason now I actually had to look for the IP address being present, and then I knew it was actually connected. While that's going on, it'll do a slow flash on the LED just to indicate that it's doing that. Interesting thing, if I use DHCP, it seems to go into this routine and takes a second or two to set up the DHCP. If I'm using non-DHCP, where I set the IP address and things, then it just drops straight through here. It doesn't really need to wait for that. Then the final part of this is just setting up the NTP time. So I go out to the I set a timeout for NTP time. I don't know whether I strictly need that. I think there's more a part of pyPakr needing that. If I've passed the NTP host name, then it sets up that. Then it sets the time based on going to the NTP server, and then after it just does some quick flashes so I know that it's made it through all the way through the connect process, and then back up to main after the connect. I'm just printing out the connection. So let's have a look at this running. So I'm just going to use a hard reset device. And there you see it ran through, and it's shown me the connected IF configuration information at the end. So I'm bringing some of the network test code over from OurProbes. First one was this uping code. I cleaned it up a little bit. I wasn't getting random strings of characters like I thought I was, so that's working now. I just put some more asserts in there, and to test it out, I put at the end of main down here after the connect, print out my connection information. Then I'm importing uping and doing a ping to my development machine with a size of 100, and then printing out the results. So let's try running that. Okay, so there's the results there. Round trip latency is about 4 milliseconds. TTL is 128 and size is 134 And just to check that that's all valid, I had Wireshark running at the same time on my development machine, and you can see here that it's showing that the length is 134 on the network, which is good. That's going to be important. I can look in here and see the actual data. So that looks like a random string of numbers, so that's good. So compression should make a difference to the ping times. So the next routine I brought in from OurProbes was the Bing routine, and Bing routine works by sending different length icmp packets to a target, comparing the times that they take to come back for like a small icmp packet versus a really large icmp packet, and estimates the bandwidth in bits per second based on that time difference. Also, because of the latency that's in the Olimex device for talking to the network driver, it also does some local tests as well to just get a baseline for how fast the network interface on the Olimex can get packets out, just so it doesn't affect the overall Bing times. So let's try running this, and just note here in the test code for the Bing, I actually turn quiet off, so we should be able to see all the pings happening during the Bing run. So we should be ready to go here. Let's fire up the device again. We'll connect to the network. So we got the ping results, and now it's firing off local different length ICMP requests, and then out to the target host, and does some calculations on the differences, and works out that the bandwidth when I ran this was about 46 megabits per second, round trip latency about 84 milliseconds, and 84 milliseconds kind of sounds right for, in this case, a host that's located in France, and all the connections over there should be pretty fast, so it's not out of the world to think that it'd be getting 46 megabits per second, maybe even faster, but it's a good sample of what the network was giving me as throughput at that time. The final test I brought over from OurProbes is the webPage tester, which gets the response time for the web page, check whether a certain piece of text is on the web page or returned by the web page, and also picks up the HTTP result. So I did the same thing again, just put a little test stub in here into the main routine. I actually commented out the other two tests, so it doesn't slow down running this. And then I'm doing a test for Lupincorp.com. Nice thing about this is I'm using a routine out here, microweb CLI. I'll put the link to that down below, but that allows you to do HTTPS requests on web pages as well as just HTTP requests. So I'm looking for my Lupincorp website, and then in the response it's expecting to see Lupincorp in the HTML for the page. And if we have a look at the Lupincorp response here, we see Lupincorp is in the title of the page, so it should pick up the string and check whether it's there to make sure we've got a valid response. And the other thing it does is returns the HTTP status, and we can see that when I run it. I turned quiet off, and this time I just wanted to see the actual results. So I've already uploaded it to the Olimex device. Let's reset it. Again, it connects to the network, and there it did the test, and it's showing 664 milliseconds response time from that website. It's saying the match was success, so it did match Lupincorp in the text of the page, which is a good sign, and also says that the status was 200. So that's a good test and shows that web page routine's still working when I brought it over from OurProbes, so I didn't have to really do much to that. So I think that's about all I'll do for this video. Next video I'm thinking I'll set up the hosts JSON file with some sample hosts in it, maybe a couple of hosts with the test for those hosts in it. so this test code won't be here anymore. I'll move that over into a sync IO routine that runs in the background and wakes up and runs any tests that are in the hosts file. I'll see whether I'll get round to making the results file after getting the results from the tests. I may have to leave that for the following video. I'll see how fast I'm going and how long the video is before I commit to doing that in the next video, but I may fit it in. But that's it for this video. Things seem to be working.